Appropriate size step for me. So I appreciate you, the stalwarts, sticking around for my topic. In this agenda, it reminds me of the game of one thing's not like the other. But I think I'm going to try to extrapolate from what we're going to talk about with robotics specifically to broader trends and even more so broader principles of innovation that are applicable to any industry. So actually, I'm hoping you find this enjoyable, but also that you learn something at the end. But I want to start real quick with my innovation department. So actually, I'll start before that with Turner. Turner, just in case you don't know, is we've been in business since 1902. We're the largest builder in the U.S. We do about $14 billion worth of work, 10,000 employees. We're the largest builder in pretty much every category of product type of building: commercial, healthcare, education, sports. Data centers is unbelievable for us right now. And we're as a result of that growth and that even the history of our founding of our company, we've always been really dedicated to innovation. So and I've been involved personally in innovative activities for almost probably 20 years at this point. And as a result of all our activities, we started to decide that we're going to put a structure around this. We're going to put a department together. We're going to focus on it. We're going to make this a part of our business and our business strategy. So I'll try to get through this real fast, but it's just generally our department, our company. I sort of, we go to these different areas. At the end of the day, we are focusing on a few, but we're trying to touch and have a portfolio view of innovation across a lot of different areas. And I'll explain why actually that's important, because actually that's the point at the end of this presentation. So we're looking at all those big trends: artificial intelligence, blockchain, robotics, obviously, because we're trying to figure out, okay, what does this mean? What does it mean for us? How can we shape this impact of these different trends? How can we leverage it for our business as, again, a business strategy to grow the business? And we have this, with that being said, it's not about, although you'll see some of the videos with the robots are pretty cool, this isn't about playing with cool, shiny objects. We have a mantra of purposeful innovation. We're doing this aligned with the business to help us reach our business goals, short and long term. So it's a constant discussion. I work actually for the chief strategy officer, and it's very deliberate in that regard. I'm not under IT, thankfully. And so we very much are trying to support the business and where the business is going. It's very purposeful. We also try to identify first problems. What are the problems in the business? Real problems, tangible problems. Let's solve those problems. Let's not, too often people take innovation and they start with a solution and they try to go find a problem. That still happens, but often we're trying to start with the problem seeking. So I'll focus a little more granularly though. We'll talk about robots. So just broadly, robotics is a fast-growing sector of innovation, if you will. Actually, the investment in robotics is doubling almost every year. The growth rate, I think, is 20% a year. You see, obviously, a lot more maturity in other markets other than construction, obviously manufacturing and such. But what we're seeing is that because of that growth and the maturity in other markets, we can take a lot of that and adapt it. We can bring it to our construction sector and then try to leverage it in new ways. So we see this clearly as an inevitable trend, an inevitable growth, and that we want to be getting ahead of it and figuring it out. For us in construction, there's what you're seeing with robotics is that the early nascent efforts, I guess, were very task-driven, and they still somewhat are. There's been a lot of work on bricklaying and even the 3D concrete printing and such. But there's also now increasingly robots that are performing services that are doing, taking labor out of an activity. We have a very big problem in our industry where we have a big loss of experienced trade labor, skilled labor, and it's an inevitable trend. That trade labor is aging. They're not being replaced by younger people. Younger people don't want to come into the trades, so it's a trend now, and it's only getting worse. It's inevitable. It is inevitable. It's probably going to be that way for decades. So, given that inevitable trend, we say to ourselves, okay, it's a problem. How do we solve that? And we're not necessarily trying to replace labor. That's very much not our purpose. It's to take away those repetitive, redundant, drudge tasks that people are doing that's not leveraging their talent and their capability. Take that and then supplement and enhance them so that people can be freed up to do value-add work. That's really our purpose. And there's a lot of opportunities, and that's what we're exploring right now. How do you, whether it's in the trades, whether it's in some of the work we do. So there's a wide range. We've been looking at lots of different applications. There's There's been robotics, and actually there's a company, Canvas, that does drywall finishing. It's an automated drywall finishing. Pretty interesting. That's been actually around for a few years now. It keeps getting better. We worked with the one in the middle there. There's a layout robot. This woman, Tessa Lau, who actually founded another robotics startup. She started Savioke. Savioke was a few years ago was a robot for hospitality. It's a robot that automatically brings stuff to your hotel room from the dead when you order stuff, a toothbrush or something. So she then came into the construction industry and now we're working with her on developing prototypes for laying out walls and scanning the space. Anyway, the other thing, the other one down below is that, talk about trades, is the overhead drilling. Hilti, working with Hilti, they got a new robot that does a lot of the automated drilling in a construction project for hangars and stuff for all your MEPs, but it automates that because it's very difficult work where trade labor has to get up on a lift and overhead and drill, and it's messy and dangerous. So they got a robot now that'll just do it automatically, just run down a floor and then drill those, and then you can hang things. It's pretty interesting. There's a lot going on. The point of that also is, what's really interesting is this is really only the past 5 years, I'd say. It's pretty recent, but what we're starting to see is an expansion into other areas and lots of people looking at different opportunities. And again, to me, that's a sign. It's a sign that we're going to increasingly be seeing this in our work. And again, how do we take advantage of that? The other interesting thing that is going to take a little time, though, is we do have to build up sort of, call it a capability or an infrastructure for it. A lot of these robotics solutions need internet connections, Wi-Fi. They have computers that they have to connect to process things, and that infrastructure really isn't in place right now on a typical job site. So again, that's okay. We look at that and we say, as long as we know that, let's start working on that piece too in parallel. And then at some point, it just converges. But it will converge. It will all come together. It's inevitable. So I want to emphasize a particular example. So Spot Robot. This is a company, Boston Dynamics. I forgot when we met them a couple years ago. And you might have seen this on YouTube and stuff. But Spot, we ended up, we started a program with Boston Dynamics. We leased the Spot Robot for roughly a year ago, to just try to test it. Like, what do you do with it? And there's really sort of three aspects of Spot that we were testing. It was Spot itself. Can the robot move? How does it move? What environment can it move within? And what can't it move within? Because that's also important. That's fine. We just know now, for now, that's not going to work. And then the second is, okay, fine, the mechanics work. Because at the end of the day, Spot's just a platform, essentially, right? Just a platform. It's what the Spot carries that's important. Because Spot doesn't do anything by itself. It walks. What you put on the back of it is important. Cameras, sensors, laser scanners is really important. And then when you get past that, the third piece is, okay, what do you do with the data you get? What do you do with it? What's the problem you're going to solve? How do you apply that? So we went through the three phases of testing: mobility, autonomy, because we want to see, can Spot, because that's a big thing, right? Ideally, in the ideal world, you'd love to have Spot, like literally you could sort of let a robot go and you walk away and the thing walks around all day, all night. We're not there yet, but it does have autonomous capabilities. So we want to again understand to what extent, how autonomous, because that's fine. What's interesting is that it all sort of, when we were testing, we didn't do that. The Spot robot's very expensive. So when we bought it, we were very careful about using it. But the point of this also is you'll see it soon. That was an early version of Spot. This is the latest. This is ours. You can see its ability. It's actually an incredibly impressive machine. The articulation of it, how it can balance. It can balance stuff on two. It can jump up and down. It can and actually, there's a choreograph module that you have to pay extra for, which they gave it to us for free, where you can have multiple robots choreographing their movements together. It's a separate module. It's like, when I first saw it, it was, and I've seen a lot of cool things. The first thing I thought, it was like science fiction come to life. It's really super impressive, super impressive. I'll show you. This is again where we're testing. What can it do? What environment? Like, that's really difficult. And that's all by itself. We're not it's figuring it out. It's literally figuring it out. It's got its own little laser scanner camera. It's got sensors on all sides. It's looking around, trying to figure out what it's got. I mean, that's like walking through a wire cage like that. We were surprised. Here's the other one. We tried it. We shouldn't have done it, but we did. Just let it walk on a pile of rubble. I mean, you can see again. See how it's adjusting constantly. It's moving. And all by itself. It's really, really impressive. Like it's pretty cool stuff. There's no doubt about it. So, but when we also want to talk, we wanted to figure out what can't it do. Here's a funny one. It was very unexpected. It has problem when there's water on the floor. Like you see, let's see it bouncing into things. It almost falls over. We had one instance where it did fall over. It actually can pull itself back up, which is amazing. And it gets so what it turns out is we discovered is we're like, okay, why? Let's be scientific, right? It's the reflection of the water affects the cameras and the laser scanner there, and it screws it up. It doesn't know where it is. But so again, okay, that's fine. Like that doesn't freak me out. Now we know that. And we know it's going to probably get better. Eventually, the software will get better. It'll get better at it. So that's okay. Or we just make sure if we're using it, we don't put it in that environment. But that's why we went through a series of sort of methodical tests, each aspect of what can do, what can't it do. And then you find the limits of it. Autonomy was that next piece. No, how autonomous can it be? So what's interesting with Spot, the way that right now autonomy for Spot is a semi-automated, which is that there's a thing they call it an auto walk. What you do is the operator with this little controller will walk with Spot along a path and then record the path, wherever long it is. And then you set Spot on a little marker so it knows where to begin and know where to end, and it will walk the path. So what's interesting about the autonomy is the auto walk's okay. Well, we're also curious, what if something changes one day to the next, right? Construction is constantly changing. The walls are going up. So this is an example. We had set a path, I think it was like the week before. When we came back, they'd started framing the walls. So the question was, okay, what did Spot do? And you can see it started walking around the walls. I'll go back. And then the other thing we wanted to, which is actually a new upgrade. One of the big limitations was battery. A battery only lasts like 2 hours, hour and a half, which is so again, when we're trying to figure out this future where can we let a robot walk on its own, independent, one of the big things, obviously, if a human has to be there changing a battery every 2 hours, then that sort of defeats the whole purpose. So Boston Dynamics just came out with a brand new upgrade, which of course we got, which is the robot will go back to a station in charge, like your Roomba, and it just sits there, and then it can leave again. So that's fully autonomous, that was a huge, huge benefit that a problem they solved. So we figured all that, right? What's it capable, mobility, its autonomy, what are the limits, and then we started thinking about, okay, what are the payloads we put on? And that was like literally the last step. We partnered with some companies like Leica, who has laser scanning, lots of different survey equipment and laser scans. They gave us a brand new laser scan that hadn't come out on the market, and that's that little thing right there. But so we use that. We put that on top. So a laser scan, just scans the space and creates this what they call a point cloud. It's accurate to whatever 5 millimeters across some white space. You can overlay that into a model. But so we used it. We started. One of the things that we started with was there's a camera and then there's this laser scan. So this is just camera, just simple 360 camera. Again, let that run around. We use those actually 360 cameras to cap throughout every day. A superintendent might walk around, use the camera, and capture progress of work. What happened, and then if there's a punch list item like QA/QC. So instead of a superintendent now, just literally because that's the thing about it. Superintendent, we pay those people a lot of money. All they're doing is standing around. They're walking all day with a camera. I mean that's not value add for a superintendent. So can we have a robot do it? Which we can. That's easy. Actually, that wasn't as easy. That wasn't hard. Then you get the laser scanner, like I said. So again, typically you'd have like these in the traditional approach. You'd have a tripod type scanner. It would sit there, and then you'd have to move it. It's very expensive and costly. But those laser scans are important because they're very accurate representations of the 3D space. We have owners now increasingly asking us to do that as a service, capture the progress of the work, measure where things are. Again, very costly, labor intensive. So with this new Leica laser scanner, which is the difference with the new Leica, which was pretty cool, was unlike the old traditional scanners, it automatically, as it walks around, it'll automatically stitch all those clouds together, if you will. And so you can come out of it with it automatically just getting a full point cloud of a space. And then you can check it against a 3D model, what have you. So we tested that. That worked fairly well. Accuracy is a little bit lower than expected. And so what it also then leads us to is where we're also increasingly getting that question from our owners are asking for what we call a digital twin, which is take the three-dimensional model that you developed during design, construction, and hand it over to the owner as an accurate representation of as-built conditions. And the only way to really make it a representation of as-built is to have that scan plus the model to make sure they're correct. So this is actually becoming a completely new sort of service or product we're delivering to our clients is this new digital twin. They then use that whole package to manage their facilities for years to come because they got an accurate representation. Our data center clients love this. They need it actually, a full 3D representation of the project after it's done. So again, Spot enables, so that's the question, right? It goes back to what problem can it solve? What does it enable? So we're increasingly trying to think about all these opportunities, and then we're starting to think ahead to okay, we got this Spot, and it'll take a little while for us to quite figure it out. I wouldn't expect Spots can be deployed widely on any job anytime soon, but although it's getting there. So where's it going? Where's robotics automation going? We have an increasing trend in the industry, our industry, design and construction, to adopt a lot more of the practices out of manufacturing, industrial for design, something they call design for fabrication and modularization. And so we're taking these new practices and we're also saying, well, wait, if we model everything ahead, we can fabricate, could we now start to adapt it to new business models? So this one on the left is a company we talked to not long ago that a robotics company had nothing to do with construction. It was just a bunch of people at MIT that have a robotics company. And we're working on a concept of this factory in a box, if you will. What can we build be bigger than a shipping container, maybe 2 shipping containers or something. And inside of that, you'd have you'd take a factory there, like car manufacturing. Have a production line, you can see the sort of production line, have the robots, 5-axis robots on the inside. They could be cutting, welding, fabricating, the architectural metals, mechanical, electrical, plumbing components. You could have a factory right on the job site that could move later, but it could be producing 24/7, just in time, on demand. And then the other idea I had was this: what if you imagined a sort of a network of these in, say, a metro area? Say you had 5 of them across a metro area, and then you connected them through software, and you're distributing the workload. Suddenly, you have this whole network of capability. That small scale, but combining it to create large scale. So anyway, but again, this idea of how can we bring the industrial concept, industrial robots into our industry, adapt it. The other one on the right is just announced. Actually, Lennar Home Builders announced that they're working with Bjarke. What's that? With Icon and Bjarke Ingels, yeah. So it's interesting, right? Their idea is take a large format 3D concrete printer and 3D print a whole neighborhood eventually. I think it's Austin, Texas, or something like that. What's that? Yeah. So it's interesting. Again, I have a personal fascination with 3D printing. About one of the first ones 10 years ago, small ones. So the technology is known. It's possible. Again, they're ambitious, bold, going on a scale that others haven't. But again, but what I love about it is, again, that these are all this automation, the robotics, all these things. Again, have been developing. They're now taking those things, applying them to new opportunities. Here's another example. Last example of this. It's just a tease. So we're working with a company. Actually, it's an architectural firm called AI Space Factory. They're a really unique architectural firm. They have an architectural practice. They do mega tall buildings. But the founder has a particular interest in space, so and we share that interest. So we've actually been working with him and NASA on things for sounds sort of weird, but lunar moon habitats and stuff. But whatever. So we're working together on that. But the technology for building habitats on the moon using 3D printers, you have to use in situ materials, no water. It's really fascinating, really good challenge. But all those technologies can also be adapted to terrestrial work here on Earth, which almost sounds funny to say here on Earth, but. So what we're doing is now we've got a smaller scale version of this that we're working on a business model to essentially set up like a reseller business where we sell the equipment, lease it, sell it, the 3D printers, concrete 3D printers to anybody who wants to use them to build whatever they can in the size. And so in April, I think it's April, May, we're going to pilot. We're going to take the first prototype, put it on a job site, and again, this idea of the pop-up factory, if you will, but with 3D concrete printing. In April, so it's fascinating. The interesting thing that I look at it, at least I find it interesting, but is that again, you're seeing a lot of these technologies have been around, they're existing. They're just starting, again, they're maturing, they're continuing to evolve, they're getting better. So I'm going to sort of take from that and actually end with some more broader principles. And that'll end with actually, amazingly, a general theory of innovation. I'm going to give you that today, a general theory of innovation. How about that? Who would have guessed? And this is, again, I've been doing this for a long time. This is based on my experience, based on, I've been studying and researching, practicing for years. And so this is actually fairly proven. And actually focus on the chart on the left, that's the one that's important. Which is, so first is that what typically happens with any disruptive innovation is that you have this, we have this red line, which is the customer demand, what the customer wants from performance. And over time, it grows. Inevitably they want more and more from their existing suppliers or whatever it is. That's fine, that's typical. What's interesting about innovation, a disruptive innovation, something that radically changes things, is that you see the yellow line. So the beginning of that yellow line is below the red line, meaning it doesn't meet performance. Like your typical client wouldn't want this thing. They look at it and they go, that doesn't do what I want it to do. And so they're dismissed. But what happens is that company or the innovation, whatever that's driving it, innovations continually improve. That they have every incentive to get better. They want to get more and more customers. They want to move up market, whatever. Innovation always gets better. That's an inevitable trend. So if that's the case, what ends up happening is that disruptive innovation nobody sort of paid attention to suddenly intersects with the customer demand. And suddenly, and all the existing suppliers, and suddenly it exceeds that performance. And so it gets better and better. We've seen that in industry after industry. It happens all the time. And so you can sort of count on that as a likelihood. The other thing I want to point out is also the research has shown, this is really interesting, that the timeline it takes for an innovation to get traction and make a significant impact in an industry. And it usually is about 15 years plus or minus 5. And different technologies are different things, but literally it's been studied. There was a study years ago of all patents in the US from 1975 to whatever it was, 2016. And they studied and amazingly enough, the rate of improvement across all of those was pretty consistent. And then you could break it down by different technologies. So robotics actually has a rate of improvement of 18.5% year over year, as it turns out. So 5 years from now, it's going to be 100% better than it is now. So if you know that, the point is you can also the chart on the right is just more what you hear typically, which is that the little hype cycle, which is, something's introduced, everybody's excited. Blockchain's classic right now, right? Everybody loves blockchain. It's fascinating. Blockchain's cool. Let's jump in. Everybody jumps in, goes, phew, the interest goes way up, and then everybody gets sort of tired and they're like, this doesn't do anything for me. And then everybody drops off. The trough of disillusionment. I don't care about it, whatever. But that's actually tricky because what's interesting is that trough is right where usually about before that thing is going to take off, which is interesting. Because also what happens is with innovations, to show it, the adoption and the impact is exponential. It follows an exponential curve. Again, proven. I'm giving you science. It's proven, exponential curve. When you look at a disruptive innovation, there's very negligible impact, very negligible. And that'll be for quite some time, again, 15. But then exponential, boom, it shoots up fast. Rapid growth, rapid adoption, suddenly, and that's the part where everybody gets surprised. Oh my gosh, where did that thing come from? I didn't see it coming, or I didn't know it was going to do that. So the point of all this is you can extrapolate rules. So I have to pull them out because I literally wrote them down for the first time half hour ago. I never thought to write them down. I was like, oh, I should do that. What did it say? So here's rule number 1 of the theory, right? Disruptive innovation. No, hold on. They're often right in front of you, but dismissed because they're inadequate at any given moment. They're dismissed. So actually, we have an internal event called the Innovation Summit. We had Mark Randolph, who was the co-founder of Netflix, talk earlier this year. And he told the story of Netflix and Blockbuster. Everybody's like, oh yeah, Blockbuster never saw it coming. No, Blockbuster saw it coming. Netflix stood in their boardroom and said, do you want to buy us for whatever, $50 million? Blockbuster knew they were there. They saw them all. It was not a surprise. They said, no, why would we do that? Nobody wants what you have. So it wasn't like hidden. That's the funny thing about disruption. It's dismissed. It's dismissed as inadequate. So that's rule 1 is that disruptive innovation is often dismissed. Rule 2, it takes 15 years, plus or minus 5, before something goes from introduction across traction to adoption. 15, 20, and then you reach that exponential growth. Rule 3 is, as a result, you have to think less like an explorer and more like a gardener. Because what it is patience. That's a long time, right? Patience. Wait, Spot Robot, for instance, right? So I'll use it, I'll apply my theory. Spot Robot right now, so robotics in construction is probably about 5 years, right? So if you say, it's been around for 5 years. So if you say, okay, robotics is going to really make a big impact 15 years. 15 years from now, or 15 years total, 15, 20, 50. So we're here year 5, you got 10 more left, and you would say to yourself, oh, that's no impact, it's too far in the future. But actually, what you want to do is back off of 10 years from now, because you want to be ahead of your competition. You don't want to be there when it does impact. You want to be ahead of it. You want to plan for it and get there. So 5 years ahead of that, you want to be ready and starting to work. But so now really what you've got is 5 years left. You got now to 5 years from now to figure out what the thing is, what it's capable of, build a business model, build your suppliers, do that, build a business around it, then start applying. So that's like, you go back to the Lennar homes. I would put in that category. Looks sort of kooky. You might look at but think about it. Whatever, they're ambitious, and what they're doing is they're learning and they're building capabilities. Because with like 3D printing, you're going to need the architect on board. You have to, contracts are going to change, labor is going to change. You're going to have the architect. Beautiful, it's brilliant to have like big architects, although good luck with that. But they're great architects, but for that home building, it's going to be interesting. So again, but what are they doing? They're learning. They're trying, they're practicing, they're developing capabilities. What it looks like now is probably not what it's going to look like 5 years or 10 years from now. But they're going to be ready. You've got to give them credit. They will be ready. And wait till that 5-year, 10-year mark. Another home builder, what are they going to suddenly develop all that capability overnight? No, they're going to get caught flat-footed. They're going to be like, because all the other home builders are going to say, oh, that's stupid. Why would you? Right now they say it's stupid. Maybe it is. I don't know. But if you take that theory, I'd say there could be something there, or at least something to watch for. So anyway, so that's I wanted to sort of lay out this idea of from that, you hear that cliche, but the aphorism, best way to predict the future is to create it. That's essentially what I was trying to give you was a theory and a framework that can be applied to anything, truthfully, to predict the future, look around corners, prepare for it, leverage it, and get ahead of it to create business opportunities, growth, and beat your competition. Can't beat that, right? There you go. That was it. I wanted to end with that thought.
So we do have time. We have time for a couple questions. If you just want to go ahead and pick people who raised their hand, we can go that route.
Did the robotics start in like a pilot program, and how long did it?
For us?
Yeah.
Yeah. No, it's still very much a pilot program. We got the one robot. We had 2 originally. We got 1 right now. We bought it. And we're just moving it. We're still in more of a testing, trying to figure out different environments. We had it in New York. We had it in some high rises. We're using it in high rises, and then now we got it at a data center. Trying different product types, different environments. See again how it operates, how it's doing, and then also again continue to think about uses and payloads. It is in contradiction to what I said at the beginning about starting with a problem. I will have to say Spot is the opposite of that. So we do have our exceptions. It is a solution looking for a problem, honestly. But again, but it's not about. Although that makes it, it's about the robotics. Again, same thing like Lennar. So we're just trying to understand it. We're trying to understand what's capable. Robotics. If I see what I see coming, we're gonna have to change. We're gonna have to hire. Think about it, software, hardware programs, robotics experts. If you're going to have a fleet of these, deploy them on jobs. So right now it's really about, okay, what does this look like? What could it look like? Where could it go? I'm very comfortable with what we're doing and investing some money because again, I have a confidence in those trends. So right now it's pilot, but again, we're going to keep growing it, and we've already had projects asking us if they could buy robots, and we're actually holding people off. We just sort of want to go through a little bit more testing. So. That's it.
Any other questions?
Do use of robotics require redundant similar activities, or can it really do very creative things, or it's
It's repetitive tasks for the most part. It's not no. So there's a lot of hype. Another hype is artificial intelligence, right? We work with a lot of startups. We see startups coming out all day. Everybody says they got an artificial intelligence solution and it's going to save us all. The artificial intelligence, that sort of creative thinking like a human, is so far off. It's unbelievable. Even the stuff you hear about from Google is not even that. Like that what they call the wide or general artificial intelligence. So right now it's about just very clear repetitive tasks in a sort of sequence, and it's not the creativity is only if you put it in the category of creativity again is its ability to sort of navigate its environment on its own.
So how do you respond when people say, "Oh, watch out, you're creating, it's going to take off, take over"? What do you mean
with
artificial intelligence, robotics?
Oh.
I hear
I have a funny job because I'm supposed to be really saying everything's great and it's going to be really cool and you're right. So I have to find a balance because the reality is, again, that chart, that time, it is real. So if I say to someone, it's 15 years from now, so I say to them, look, things got to mature. It's going to take time. There's a lot of things. Artificial intelligence, it just is. But there's a spectrum of that artificial intelligence. It starts with just business intelligence and data analytics, the early stages that we've hired. We actually a few years ago had artificial intelligence interns for summer just to try it out. And the first problem we ran into with artificial, you have to have right now, you have to have structured data. You have to have access to your data easily and structured. The 80 to 90% of even data analytics is actually cleaning up the data, not the analytics. That's a huge effort. So the reason we did that then was when we ran up to those roadblocks of why can't we do this data analytics, we then learned, okay, what do we have to change as a company moving forward? We have to really rethink our data structures, our databases, our sources, how are they connected, are they not connected? So again, what we do is we try things usually to find the obstacles and see if we can take them away. It's not about, because I told everybody when we had the interns and we had a year initiative, I said, look, I don't actually care about the outcome. I actually don't care at all. I care about the process and what you learn in the process. And we learned a lot. That we're not ready is the answer. But we're starting there. We put an initiative in just around basics, visualization, analytics. It's teaching us to structure our data. We're starting to aggregate it now. It's a multi-year effort to aggregate into a big data warehouse. We got some sophisticated analytics programs. We're working with IBM on artificial intelligence application, machine learning really, not quite true artificial intelligence, but machine learning. So we partner with IBM. Again, we're talking a lot more than anything right now. But we're getting ready, and we're actually starting to talk about an initiative. It's again, being a gardener. Just plant seeds, water, cultivate. It's going to grow at some point. And the challenge again is, we'll say in a big company, is whether the organization has patience. And I keep telling them, wait, it's going to be great. Well, we do good stuff right now, but it is it's a longer vision. It's investment in a future that theoretically may or may not come. And a lot of organizations, that's what kills innovation. And almost, again, this has been well studied and researched, and I've lived it myself. Organizations are built to do what they do well, and all the policies, protocols, the cultural norms are all built around supporting the core business. And so new innovations come in that are disruptive. If you bring it into the organization, usually they get starved. People don't, because the leadership goes, wait, I'm making money over here a lot. Why would I invest over here that's not making any money right now and may not ever? And that's almost always, that's the death trap right there. Because leadership will always do, the strange thing about why innovation dies in big organizations is that the leaders do what they're actually trained to do, which is manage a business, manage the core, protect the core earnings. And they say, oh, good, let's resource that. Let's put the best people on that. And when this other thing comes along, they say, well, why? Again, good business people. Why would I invest over here? And that's a challenge. I deal with it almost every day. It's a challenge. So my group that was part of the purpose of setting us up and under strategy was I operate off to the side of the organization. I don't follow any of the rules, actually. I don't follow any rules. But you can't. You can't move fast if you're sitting there, I got to go to committees, I got to do reports and justify this, because a lot of stuff I can't justify. Can I tell somebody, what's the ROI on Spot? I don't know. I have no clue. But for some reason, they trust me. I've grown up in the company, so I guess.
All right, one more question.
So we actually have a program, an annual program. So it's called the Innovation Challenge, which we started 5-6 years ago, which is an annual thing. We do it once a year. We'll go out soliciting. We have categories of the business that we're looking for innovations in or problems we want to solve. Categories, three main, and then we'll go out to the company. The entire company will announce it, and give them whatever 30 days. They can submit their ideas or solutions that they have. And the interesting thing is, it started originally as more of a cash award type program, which I hated, but it wasn't in my court at that time, because it created weird incentives. I don't want to pay people to innovate. They should feel intrinsically like that's what they want to do and who they are, not, oh, I'm going to get cash. So we got away from that. And the other thing, truthfully, when we did that, we get, I don't know, 500, 600 ideas. I'll be honest, there's not a lot of them that were monumental, because it's not people's fault. They know what they know. You ask them to innovate, they can think adjacent, but not big leaps. So we then migrated about 2 years ago to this Innovation Challenge. We do the solicitation, but actually what we're looking for are the people, not the ideas. And we find the big thinkers, and then we bring them together in a structured workshop that we run. And then we go through a 3-day workshop. We call it using a design sprint methodology. And we work through, again, problem solving, and then you get 12, 13 people that by the end of that workshop, they're working together to solve some problems as a team. And then we let them go. Well, we manage them, but then we work on them. And then so that structure's worked really well, because you really do have to crack people's brains open. It's like a manual effort. It's not natural for people. So we use that workshop to get people to think big, and then we help them through the process that process is also towards the goal of actually implementing something tangible. We're going to get to the end, and we're going to do something. We're going to roll something out in the company. And we've had a whole series of things we've rolled out. Some success, most successfully. There's a few that have been challenged, but you have to have that structure. It's not natural. It's not, the organization's not going to do it on its own. You have to cultivate, you have to teach, you have to educate people. That's all part of that building a culture of innovation. I like to think we're pretty good at it, but we got a lot more work, that's for sure. Our next thing is actually we want to go more external. We work with a lot of startups, but doing some more external challenges, going public with some of the problems and see what comes to us from around the world. We're very interested in actually getting into the European startup communities. Germany, Berlin's got something. Tel Aviv's phenomenal. So now we're going a little bit bigger global picture is the next step. But yeah, we always start with the employees. They need a mechanism for their voice to be heard and to engage in bringing change.
All right, we are just about out of time. That was incredible. Please give Jim a very warm round of applause.